If the radicand of the nth root of a has a perfect nth power among its factors, you can reduce the radical. If you reduce a radical as much as possible, the radical is in simplest form. For example, consider the square root of 24 and the cube root of 24. The square root of 24 can be rewritten as the square root of the product of 4 times 6. Now 4 can be rewritten as 2 squared, so our expression becomes the square root of 2 squared times 6. That can be split apart and written as the square root of 2 squared times the square root of 6. And the square root of 2 squared is simply 2, so our simplest form becomes 2 times the square root of 6. The cube root of 24 can be rewritten as the cube root of the product 8 times 3, which is the same as the cube root of 2 cubed, equivalent to 8, times 3. This expression can be split and become the cube root of 2 cubed times the cube root of 3, and the cube root of 2 cubed is 2, so we have 2 times the cube root of 3, our expression in simplest form. Problem 2. Simplifying a radical expression. What is the simplest form of the cube root of 54x to the 5th power? Well, first we rewrite our expression, the cube root of 54x to the 5th, and then we write that as the cube root of 3 cubed times 2, 3 cubed being 27, and 27 times 2, 54, times x squared times x cubed. Notice what we've done is we've found and separated all the perfect cube factors. Then we group those perfect cube factors, and it becomes the cube root of 3 cubed times x cubed times the cube root of the leftover factors, 2x squared. Recall we can do this by the property that states the nth root of a times b equals the nth root of a times the nth root of b. Simplifying, we find 3x times the cube root of 2x squared. Your turn. What is the simplest form of the cube root of 128x to the 7th power?